Greetings and salutations. Here's another example of optimization for you. I keep trying to ramp these up a little bit so you can see the different kinds of complexity that you're going to have to deal with. Here's another box, but this time you have a box that's given to you. Well, you're not building it, it's given to you. It's square base, open top, so it ends up, this starts out the way the other one ended up, but it must have a volume of 32,000 cubic centimeters, so they're giving you the volume. They want the dimensions of the box that minimize the amount of material used. All right, so this is pretty realistic with, if you think of shipping and manufacturing and all that. So they're trying to find the dimensions of the box that minimize the amount of material used to be able to carry something or contain something that holds 32,000 cubic centimeters. Okay, so let's draw a picture. We have an open box, open top with a square base. So, I don't know, something like this. Square base, right? Square base. Now it doesn't mean it didn't say it's a cube. I know I didn't draw it so great. It almost looks like a cube, but I don't know what the height is, so I'm just going to call it h. Right? It could be like that. It could be like this. I have no idea right now. All I know is it has a square base with an open top. So there's nothing up here. It's just open. I don't have to worry about it. All right. So there's my picture. I'll just focus in on this one. It doesn't really matter. And they're telling me the volume is 32,000, right? So if the volume is 32,000, well, the volume is x times h, so x squared h, and that's 32,000. Great. All right, done. Problem's over. Not quite. We're trying to minimize the material used. That's not volume. Material used would be surface area. So the surface area, we have the bottom, which is x times x, plus 4 sides that are all x by h. So I have 4 xh's to deal with. I don't have the top because they said it was open. So I don't need 2 x squareds, right? I just need the one bottom. So that's the bottom. And then I have 4 of these xh's, right? xh, 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 right? There's 4 of them. So there's my surface area, and that's what I'm trying to minimize. So this is a little bit like the first one on steroids, basically, because now your substitution is going to be a little more complicated. Your derivative is going to be more complicated, but it's the same strategy. Kind of like related rates, when we would always have to switch one out for another. I don't know about you, but I think solving for h is going to be a lot easier than trying to solve for x or x squared, because there's multiple types of x's here. So I'm just going to solve this one for h. So h is 32,000 over x squared. Done. Plug that in. So my surface area is going to be x squared plus 4x times this 32,000 over x squared piece. There's my formula for surface area. That's what I'm trying to minimize. I can go from there. Theoretically, you could put this in your calculator, do an end deriv, find the critical values, and go from there. But I think this is probably, I don't know, this might be right on the threshold of something I think you should really be able to do by hand. And you'll see when the numbers start settling out that it's not as bad as it may seem. So I'm going to do it by hand to show you. If you want to pause it and try it yourself first, I would respect that. Otherwise, I'm just going to go ahead and do it. So here we go. So, well, first of all, let's clean it up, right? So x squared plus 128,000, right, over x. There's my surface area. And when I go to do my derivative, I'm sorry, if you're still doing quotient rules on things like this, I don't know what's going to convince you that it's not worth the effort doing it that way. Rewrite it. Rewrite it. It's just a constant. This is just a constant, so just change that so that your derivative is easier. Do a little power rule and go from there. So let's take our derivative now. That's going to be 2x minus 128,000, x to the negative 2. There's my derivative. I could graph that and find the critical values based on where this crosses the x-axis or where it might be undefined. But I think I could do this by hand. So this is going to be 2x minus 128,000 over x squared. Get a common denominator. That's going to be x squared. So this is missing an x term, right? Or excuse me, this is missing an x squared term in the denominator. So this is actually going to be 2x cubed minus 128,000 all over x squared, right? 2x cubed, 128, and x squared. Let's see. I'll continue it up here. Remember, you can always pause and rewind if you need something. So obviously, when x is 0, right? Let me get back on the screen here. When x is 0, we have a critical value, but that doesn't really make sense because what are you going to do? Look at the box. You're going to have a dimension of 0 by 0 by something to get, 32,000 for your volume? I don't think so. So that solution algebraically and calculusally, I don't know, makes sense, but it doesn't make sense in the context of the problem. So where's my other value? Line that up better. Okay, there we go. So I really want to know when 2x cubed minus 128,000 equals 0, right? That's what I'm looking for. That's where I'm going to get a good critical value. So let's clean that up. That's 2 times x cubed minus 64,000. So that means x cubed minus 64,000 would have to equal 0 for this to work. X cubed being 64,000 would mean that x has to be, what's that got to be, 40, right? The cube root of 64 is 4. So the cube root of 64,000 is 40, right? So there's your value for x. So now when we go back to our picture, I know this is going to be, here, I'll use this one out because I have a little more room. I've got a 40 by 40 by something. Well, to get the something, I can go back to my original equation. Actually, I could do it here. It'd probably be easier to do it here, right? H equals 32,000 over x squared. So H equals 32,000 over 40 squared. So that's 32,000 over 1,600. Clean that up. 320 over 16 is 20. So this is, I didn't draw it to scale. This one actually looks better, but it doesn't matter. I wouldn't have known. Oops, H is 20, sorry. Okay, so it's 40 by 40 by 20. So the dimensions are 40 by 40 by 20. And how did the question get asked? It was find the dimensions of the box. Okay, it didn't ask me for the actual surface area. Of course, I could figure that out if I wanted to. I could just plug these numbers in. But there are your dimensions for this box. Okay, so just to clarify again, draw your picture, bang or bang, doesn't really matter. Use the information given to come up with your formulas. You got to sort of translate the idea of material used as surface area. Substitute one for the other. Pick the easiest version. I really don't think you're going to want to solve this for x and then try to plug that into these, two spots, because then you're going to have a square root to worry about. It's going to be more annoying. And then just clean it up. And you see the numbers weren't that bad. I know some of you who are using your calculators today to multiply a half times a quarter, are going to disagree with me, but I really think at this stage of your mathematical careers, this is pretty much doable. And then it continues again to here. Okay, all right. Again, I could graph it and check it. I could do the number line, but at this point, I think you're getting the idea. So I'm going to leave it there, and hopefully that helps. And I will talk to you later. Peace.